Okay, here we go. One more quick example because these cylindrical shells can be quite challenging in the way that they make us think. So we want to use shells to find the volume of the region revolved around the y-axis. Here's our boundaries. So that means that the region we're interested in is in here. So we want to find the region of this guy revolving around the y-axis. So if you'll go back to your previous slide and look, then what we're doing is we're going to integrate according to x. Okay, we're going to integrate according to x because we're revolving around y. It may be easier to see the shell with this one. So here's the height of my shell right here. Here's my shell height. Okay, from way up here to right here on this x, the line y equals x. My shell radius then is going to go from 0 out here to whatever value I need, okay? And so when I set this guy up, he's going to follow the same rules that we did on our previous problem. But this time, since we're going around the y-axis, okay, we're rotating this way around a y-axis, so like a Pringles can, okay? Then we're gonna find where this point of intersection is, and I use my graphing calculator to do this. You could set x equals 4 minus x squared and solve it out that way as well. So we're going to integrate from 0 to 1.562. We're going to have 2 pi in the front. We're going to have the shell radius, which is the x coordinate, okay, times the shell height. And the height on this one is just from that line from 4 minus x squared to x. But remember, we're not going past 4 either. It's like we've got this invisible line up here at 4, so we want to know all the area under here, but only that area under there. So when we set that guy up, we're going to have 4 minus x squared, which is this upper line, the reddish one, minus the line that we stop at, so the whole top minus bottom thing. So 4 minus x squared minus x. Now remember, in the previous problem, we had a vertical line there, which allowed us to just put the number 4 in and subtract from that. So top function minus bottom function, and so it's going to look like this right here. And when we integrate, since we've got the 1.562 in, I would say go ahead and use your calculator on this one, because dealing with decimals, doing integration, there's lots of room to make a mistake. So we're going to have 4x minus x cubed minus x squared, and all of this is dx to represent our change, our small changes, but horizontally. Okay, so punch this into your calculator. It's not hard. And when I do that, I get 13.327 units cubed. Let me make sure. 14.327 units cubed. Okay, so there you go. There's another shell guy. Could we also find the same area using washers and revolving around the x-axis? Yes, we can, and that's what's so neat about shells and washers. You've got 2 ways to solve it. So some of you guys may look at this problem and go, man, I see the shells, it's not a problem. Some of you guys will look at this and go, I see washers. Hey, guess what? Not a problem. But follow the directions in your book, follow the directions on your exam. Whatever method they ask you to use, you'll want to do that. And sometimes it's easier to use one as opposed to the other. It just depends on the problem. All right, so there you go. More cylindrical shells. I think this is just really cool stuff.